Carlos, a professor from Durham School, shares that throughout his lifetime, he focused on developing a precise and well-defined theory of the universe he now observes. As this hypothesis is put to the test, it's something he welcomes, recognizing that science advances through such challenges. The James Webb Space Telescope is revolutionizing and challenging many long-established concepts in cosmology, revealing an entirely new view of the cosmos. As we enter the new year, the telescope's ultra-deep field image has shown that there 33 seconds are significant errors in our previous understanding of the universe. Initially designed to uncover the first stars of the universe, this telescope is evolving into a challenger to past ideas and may bring about an entirely new approach to cosmology. However, not all scientists are afraid of these revelations. Many experts in the field embrace these changes because it had become increasingly evident that something was amiss with the older theories. The consistency in calculating the universe's expansion. 1 minute and 1 second rate should have raised doubts about earlier perceptions, but for a long time, experts held on to old assumptions. The cosmic microwave background, CMB, regarded as the oldest light in the universe, originated about 380,000 years post-Big Bang, when the universe cooled enough for protons and electrons to bond and create stable hydrogen atoms. This period, known as reionization, allowed the universe to become transparent to light. In 1964, American physicists Arno Penzias and Robert Wilson made a breakthrough. 1 minute and 35 seconds discovery while working with new radio antenna technology. They detected the CMB. This finding was long considered one of the strongest pieces of evidence for the Big Bang theory, earning Penzias and Wilson a Nobel Prize and securing their place in the history of astronomy. The CMB offered scientists a unique look at the early universe, revealing small temperature fluctuations that helped provide insights into the conditions that followed the Big Bang. The CMB was also used to test the expansion rate of the universe and 2 minutes and 5 seconds verify other cosmological assumptions. As early as the 1920s, astronomer Edwin Hubble had established that galaxies in the far distance were moving away from us, with their speed correlating to their distance. This observation led to what is now called Hubble's law or the Hubble constant. While Hubble did not have the advanced observational tools available today, his discovery, alongside the later finding of the CMB, led to recalculations of the universe's expansion rate, which turned out to be slower than Hubble's original estimate. The divergence in these calculations has been a point of contention for scientists for decades, with many researchers realizing that something was fundamentally wrong with how the CMB and standard candles were calculated. Later, astronomers used Type Ia supernovae, known as standard candles, as reliable measurement points to gauge cosmic distances. These recalculations, based on the CMB, suggested an expansion rate of approximately 67 kilometers per second per megaparsec, while data from supernovae indicated a higher rate of approximately 74 kilometers per second per 3 minutes and 10 seconds megaparsec. The expansion rate of the universe was being interpreted inconsistently. This discrepancy, known as the Hubble tension or Hubble strain anomaly, suggests that there are flaws in our basic understanding of the cosmos. These discrepancies have profound implications, challenging our most fundamental beliefs about how the universe works. The issue has been known since the 1990s, when scientists began to suspect that there were errors in the methods used to measure the CMB or perhaps even in the assumptions made about the universe's expansion over time. 3 minutes and 40 seconds, the discrepancy between observed and predicted expansion rates became increasingly apparent. The Hubble tension suggests that our theories may need a drastic overhaul, indicating that key elements of our cosmological model could be deeply flawed. Now, with the advent of the James Webb Space Telescope, researchers are gaining extraordinary new data that may help resolve the issues with our understanding of the universe's expansion rate. These new findings are so profound that they could shake the very foundation of our 4 minutes and 10 seconds previous cosmological theories. The telescope is revealing galaxies and systems so ancient and evolved that they suggest the universe's evolution could have begun well before the Big Bang. This challenges the old cosmological views, forcing scientists to reconsider the nature of the Big Bang and the expansion of the universe itself. Instead of merely talking about errors or discrepancies in data, scientists are now addressing what many describe as a crisis in current cosmological models. It's no longer just 4 minutes and 39 seconds about miscalculations. It's about rethinking our very conception of the universe. The new data from the James Webb Space Telescope reveals a cosmos far more surprising than anything previously imagined. The Hubble tension, once a source of confusion for those holding on to traditional theories, is now a focal point for scientists who must confront the possibility that our understanding of the universe might need to be completely redefined. As scientists continue to investigate these unprecedented discoveries, they are also 5 minutes and 10 seconds confronting the larger question: do we truly understand the universe? To answer this, it's important to grasp how science operates. Cosmologists employ intricate mathematical models, careful analysis of data, and logical reasoning to make predictions and test hypotheses. Their conclusions are based on a combination of empirical evidence, well-established principles, and theoretical calculations. However, it's important to remember that science is a dynamic field, and theories are always subject to change as new data. 5 minutes and 42 seconds comes to light. The future of cosmology, unraveling the universe's mysteries. As the James Webb Space Telescope continues its mission, its observations are not only refining our understanding of cosmic history but also pushing the boundaries of what we once thought possible. Scientists now face a crucial turning point. How do these new discoveries reshape our models of the universe? One of the most striking revelations is the unexpected maturity of early galaxies. The JWST has detected fully formed galaxies that appear far earlier in cosmic history than anticipated, challenging the widely accepted lambda CDM, lambda cold dark matter model, which describes the structure and evolution of the universe. If galaxies formed and evolved more rapidly than predicted, it may indicate that our understanding of dark matter, dark energy, and gravitational interactions needs revision. At the same time, JWST's spectroscopic data is revealing atmospheric compositions of exoplanets in unprecedented detail. The search for potentially habitable worlds is no longer a distant dream. Scientists are now identifying planets with conditions that could support liquid water and possibly life. This raises an even deeper question. Are we alone in the cosmos? A universe of possibilities. As astronomers analyze Webb's findings, new models of the universe are emerging. Some researchers propose alternative theories of gravity, suggesting that Einstein's general relativity may require modifications at cosmic scales. Others speculate that dark matter may interact with normal matter in ways we have yet to detect. Meanwhile, the nature of dark energy, the mysterious force driving the universe's accelerated expansion, remains one of the greatest unsolved mysteries. Could JWST's deep field observations provide the key to understanding it? Or will they uncover an entirely new force of nature that redefines physics as we know it? These questions, once confined to the realm of speculation, are now being addressed with real data. The cosmos is speaking, and we are finally listening, armed with the most powerful telescope ever built. The dawn of a new era. Every discovery made by JWST brings humanity closer to answering the most fundamental questions about our origins, our fate, and our place in the universe. As more data pours in, scientists around the world are working tirelessly to interpret what it all means. The next few years may be transformative. With upcoming missions like the Nancy Grace Roman Space Telescope and future gravitational wave observatories, our ability to probe the cosmos will only grow stronger. The dream of a grand unified theory, one that ties together gravity, quantum mechanics, and cosmic evolution, may soon be within reach. But perhaps the greatest lesson from these discoveries is this: the more we learn about the universe, the more mysterious it becomes. And that is the beauty of science. Each answer leads to new questions, new frontiers, and new possibilities. The James Webb Space Telescope is not just a window into the past, it is a beacon guiding us toward the future, toward a deeper understanding of existence itself. Beyond the horizon, the next chapter in cosmic exploration. As the James Webb Space Telescope, JWST, continues to unveil the secrets of the cosmos, its latest findings push scientists into a new era of exploration. The discoveries so far, mature galaxies in the early universe, atmospheric signatures of exoplanets, and anomalies in cosmic expansion, hint at an even greater truth lurking beneath the surface. But one recent observation has sent shockwaves through the scientific community. A signal from the cosmic dawn. In its latest deep field survey, JWST detected something astonishing, an unusual pattern in the cosmic microwave background, CMB, the afterglow of the Big Bang. Unlike the expected smooth variations of temperature and density, this region contained anomalies that defied all predictions. At first, astronomers assumed it was an instrumental error, a glitch in the data. But after weeks of verification, the signal remained. It suggested something extraordinary, a structure embedded within the CMB, unlike anything seen before. Some theorists speculated it could be the imprint of a previous universe, evidence that the cosmos has undergone cycles of expansion and collapse. Others wondered if it was a signature of an undiscovered force, one that shaped the fabric of spacetime itself. Yet, the most controversial interpretation came from a group of researchers analyzing the signal's mathematical properties. They found patterns too precise, too structured to be random. It was as if the early universe had been imprinted with information. The cosmic code. Are we in a designed universe? This revelation sparked an intense debate among physicists and philosophers alike. Was this a natural phenomenon, an unknown quantum effect that shaped reality? Or was it something far stranger, a message written in the very structure of the cosmos? One hypothesis suggested that if the universe had been fine-tuned for life, perhaps it had been engineered in some way. The idea of a simulated universe, once relegated to the realm of science fiction, now had a new wave of supporters. But if we were living inside a cosmic construct, who, or what, created it? The search for answers. As these questions swirled through the scientific community, space agencies began preparing for the next phase of exploration. Plans for a quantum telescope, one capable of detecting spacetime distortions at the smallest scales, were accelerated. Scientists proposed using gravitational wave observatories to scan the cosmic fabric for artificial structures. Meanwhile, deep space probes, equipped with advanced AI, were being designed to venture beyond the solar system, searching for anomalies, places where the laws of physics might break down, revealing the hidden architecture of reality. First contact. And then, just as the world was grappling with the implications of these discoveries, another signal arrived. This time, it wasn't from the early universe. It came from a distant exoplanet, orbiting a star 12,000 light-years away. Unlike previous detections of simple radio bursts or unexplained flashes, this transmission carried a clear mathematical structure, a pattern that could only have been created by an intelligence. The race was now on. Had the JWST, in its quest to understand the cosmos, stumbled upon evidence of another civilization? Or had humanity just taken its first step toward uncovering a truth far beyond anything we ever imagined? The future awaits. With each discovery, the boundaries of human understanding expand. Whether we are on the verge of proving the existence of other intelligent beings, uncovering the secrets of dark energy, or realizing we are part of a vast, interconnected cosmic network, one thing is certain. The universe is far more mysterious than we ever dreamed. And we have only just begun to unravel its secrets.